Hello, this is Tyler Beamer, math instructor at Haywood Community College. This is an instructional math video for DMA 030. This video is in regards to Module 3, Section 4, Congruent and Similar Triangles. So let's first talk about what the word congruent means. Congruent means that two triangles have the same shape and the same size. So essentially, if two triangles are congruent, they are identical. Okay, so oftentimes we have missing information in the triangles. So I'm going to show you some geometric theorems which will allow you to determine whether two triangles are congruent given certain pieces of information, and then of course other pieces of information will be left out. So one of those theorems is angle side angle. So what it states is if we have two triangles, okay, and then we have the angle measure of two of the three angles of a triangle. So notice that one of the angle measures is missing. And we have the side length of the included side. And so what the included side means is that it is the side that is between the two angles. Okay, so essentially it is the side length that is used to form, those angles. Okay, so you can see here in both of these triangles we have the angle measure 45, 35. And in the other triangle, we also have that same angle measure, and we have the included side length in each of those 14. And so because those measurements in each of those triangles are the same, we could then conclude that the two triangles would then be congruent with not even knowing the other two side lengths or the other angle measure. Okay, so that's one theorem to prove congruency among triangles. Another theorem that we could use is side, side, side. And this one is the most obvious. If you have all three side length measures of the three sides of a triangle, and those side length measures are the same as another triangle, then those two triangles would then be congruent. And I wouldn't even have to know the angle measures in order to determine that. So obviously these side lengths fix the angle measure in each of those triangles, then making them both congruent. So these two triangles would have the same shape and then the same size. And a third is side angle side, and in this particular theorem we have two side lengths of a triangle and the included angle. So it is the angle that is between the two side lengths. Basically the two side lengths come together to form that angle. So if we have that piece of information and another triangle has those same measurements and those same sides and angles, then of course the two triangles would then be congruent. We would not need to know the other two angles or the other side to determine that. Okay. So in your homework, there's not a lot of arithmetic involved with these particular types of problems. A lot of it is looking at figures, determining whether triangles are congruent just based off of the information that's given. So I would definitely go back to these three theorems to determine that. All right. So next is similar triangles. Okay, so similar triangles are triangles that have the same shape but not necessarily the same size. Okay, so it's kind of like if you drew a figure on a piece of paper and then you went to the copy machine and then you expanded it 200%, right? It's going to be twice as big as what you drew. Or if you went to the copy machine and you reduced it 50%. It's going to be half as big as what you drew. So it'll be the exact same figure, right? The angles will all be the same, so it has the same shape, just not necessarily the same size. So here we've got two triangles that are similar. You can see that they have the same shape, and the fact that they're both right triangles, they're obviously not the same size. So one of the key concepts with similar triangles is that corresponding sides of similar triangles are proportional. Okay, so let's first of all find the ratio of the corresponding sides of triangle A to triangle B. So we're going to label these triangles A and B. And notice how this is written, A to B. So we want to make sure that we write our ratio in the right order. A to B would look like this, right? Where the side length for A would be on top and B would be on the bottom. Okay, so then what is corresponding sides? So corresponding sides are sides that are in the same position in each of the triangles. So 8 and N, those are both the hypotenuse of those right triangles. So those would be corresponding sides. 9 and 18 are corresponding sides. They're both legs, which in this case is the base of each of those triangles. So corresponding sides means that the sides are in the same position in each triangle. So if I want to find the ratio of the corresponding sides, then of A to B, got to be careful of the order. Let's use these two corresponding sides. So 9 to 18. And so if I reduce that, I get 1 to 2. So basically that tells me that triangle B is twice as big as triangle A. Okay, so that answers the first question. Second question says, find the length of the sides, label N in the following pair of similar triangles. So this is where we would set up a proportion. Remember that corresponding sides of similar triangles are proportional. So essentially, I want to set up a proportion, and I'm going to make sure once again that each side of the proportion is set up the same way. So A to B equals A to B. So one pair of corresponding sides is the 9 to 18, like we just wrote. And so the other ratio would be 8 to N. These two sides are corresponding sides of the triangle, and of course A to B, so we get it in the right order. And so that sets up a proportion that we can then solve for N by cross multiplying. So we take our cross products, 18 times 8, which is 144, 9 times N, which is 9N, and then we divide to find the value of N. So N equals 144 divided by 9, which is 16. So N would equal 16. And of course, that makes sense, right? We just figured out over here that triangle A is half the size of B. B is twice the size of A. So 9 times 2 is 18. 8 times 2 is 16. So that answer makes sense. All right. So that's how we can use rules of proportions to help us solve problems involving similar triangles. So here's another example. So Melrose is a 6-foot tall park ranger, and here is the park ranger, and 6 foot tall, so that's already labeled for us. Who needs to know the height of a particular tree? He measures the shadow of the tree to be 69 feet long. So that is the length of the base of this right triangle. So you can imagine if the sun was here shining on the tree, on this side of the tree, that would form a shadow. Okay, so And his own shadow is 9 feet, so that's the base of this other right triangle. So we can see that this basically sets up 2 right triangles. And of course these 2 right triangles would be similar, have the same shape, obviously not the same size. And then we want to find the height of the tree, which is this side of this right triangle. So we can use the ideas of similar triangles to help us solve for that. So once again, I'm going to label these triangles A and B. Okay, make sure that we set this up correctly. So our proportion, we could do A to B, and we want to compare corresponding sides. So the corresponding side for A to B over here is 9 to 69, right? This is the base of this right triangle. This is the base of this right triangle. And then we can compare the height of each of the right triangles. So the height of A is 6 feet, and the height of B is unknown, N, that's what we're trying to find. Okay. So now we can cross multiply to solve for N. So 69 times 6 gives us 414. 9 times N is 9N. And then so we would want to divide both sides by N. So N equals 414 divided by N. Or I'm sorry, divided by 9. So we get 46. So 46 feet. And of course, that answer makes sense, you know. Height of a tree could certainly be 46 feet tall, so that answer seems to be in the ballpark. Alright. Hope this video helps. If you have any other questions, please email or call the office or come by the office. Alright, have a great day.